Academy. Today we'll be looking at chemistry, the mole, chapter 6 in most books. Okay, but we'll be looking at the IGCSE concept. Okay, so this chapter is the mole concept. We're looking at mole concepts and chemical formulas and equations that goes with it. So without much ado, let's move. Here we'll be covering the relative atomic masses and relative molecular masses of atoms. Relative atomic masses and relative molecular masses of atoms, right? Then the next one will be the mole concept itself, and then chemical formulas and their chemical equations. Now let's take a look at the second one, which is the one we're looking at today, the mole concept, right? The mole concept. We said the chapter will be the mole concept, chemical formula, and chemical equations. So we're covering mole concept 3.2, chemical formula 3.3, and chemical equation 3.4. Okay, 3.1 is in another slides. Will be part 1. This is part 2 of this work. Now let's take a look at the mole concept. Here we'll be looking at defining the mole, and we'll be looking at we relate the mole and the Avogadro's constant and the number of particles with the formula that relates the mole, the Avogadro constant, and the number of particles in an atom. Then we look at the meaning of molar mass, and then we relate the molar mass and the moles with a formula. We create a table of formula to relate the mass, the molar mass, and the mole. And then we say the meaning of molar volume, and then we will look at the volume, and then we look at the relationship between the molar volume, the volume, and the moles with another formula. Then we solve numerical problems. So this what this concept is. Now let's start with the first one, which is the mole. Let's just go back to our everyday life. We say a pair of shoes equals to what? 2 shoes. When you hear the word pair of shoes equals to what? 2 shoes. So pair of shoes does not mean 1 shoe. It means 2 shoes for both left leg and right leg. So if I say 2 pairs of shoes means I will get 4 shoes. If I say half pair of shoes, it means I'll get 1 shoe only, maybe for the right leg or for the left leg. Okay? So that relationship kind of relates with mole. When we say a dozen of pencils, means we get 12 pencils. If you say 2 dozens of pencils, because 1 dozen is 12. When you say 2 dozens of pencils, you get 24 pencils. If you say half dozens, means you get 6 pencils. Then if you say 3.5 dozens, means what? Means you get 42 pencils. Why? 1 dozen is 12, so 3 dozens will be 36, plus 6, 36, plus 6, you get 42. Now, the amount of a substance can be quantified by using the unit called mole. You can quantify any substance by using what? The term mole. So you can say the mole is the amount of a substance, right? We can use it to quantify anything. So like pairs and dozens, mole is the unit that represents certain number in chemistry. So 1 pair is 2, 1 dozen is 12, 1 mole is what? It has its own number. Like you say 1 pair is 2, 1 dozen is 12, 1 mole will be 6 sextillion, 6 sextillion number, which is 6.02 times 10 to the power of 23 Avogadro. This number is called Avogadro. It's the number of particles in 1 mole. There are 6.02 times 10 to the power of 23 particles in every single mole. That's what it means. When you take 1 mole, there are 6 quadrillion or 6 quadrillion number of particles in 1 single mole. So this number is the defining characteristics of a mole, and this number is called the Avogadro's constant. It's called the Avogadro's constant. So we're going to relate the mole with number of particles. Mole equals to number of particles divided by this Avogadro's number. So mole will be number of particles divided by Avogadro's constant. So when we say mole, so I use M for mole. Okay, I just use MOL. Mole MOL is equal to the number of particle. So I use P for number of particle. Number of particle or number of molecule over the Avogadro's constant. Avogadro's constant, we can use capital letter N, or we use, we can use capital letter N, which is this number, this Avogadro's constant, this one. This is the Avogadro's constant. So number of mole, okay, the first formula for mole is the particles in any atom, the number of particles in any atom divided by the Avogadro's constant. Is that okay? So we move on to the next one. Okay, so atomic substance. Let's take a look at atomic substance. You take any substance. Let's take a look at the atoms in a substance. You know, an element is a substance that contains only one type of atom. Okay, because it's a pure substance. An atom is a substance. An element is a substance that contains one type of atoms only. So when you take any atomic substance, 1 mole of copper, for example, let's say this is copper, like you know copper wire, right? 1 mole of copper equals to 6.02 times 10 to the power of 23, right? Atoms, copper atoms. 1 mole of copper is 6.02 times 10 to the power of 23 copper atoms. Is that okay? Similarly, molecular substance, 1 mole of water, you're looking at molecule now. This is a molecule. You know there's a difference between atom and molecule. Atom is just one entity, right? Molecule is probably either combination of more than one atom or combination of more than one element. Okay, like in this case, there's hydrogen and oxygen combined together, chemically combined together. So this is 1 molecule of water. So 1 molecule of this water contains the same number. So this is in this case. Now, if you take ionic, first we look at it from atomic point of view. In terms of atoms, 1 atom of copper contains what? 6.02 times 10 to the power of 23. Okay? In terms of molecule, 1 molecule of water, molecular substance, 1 molecule also contain 1 molecule of water contain 6.02 times 10 to the power of 23 particles. Then, in terms of ionic substance, in terms of ions, 1 mole of sodium of 23. So that's the significant differences between them. Now let's move on. If you take a look at them, you say 1 mole of atomic substance contains this number, 6.02 times 10 to the power of 23, right? So for all 3 of them, they contain the same thing. In this case, atoms. 1 mole of atomic substance contains 6.02 times 10 to the power of 23 atoms and molecular substance. Here, 1 mole of ionic substance contains 6.02 times 10 to the power of 23 formula unit. Here, because we're looking at ionic substance. Okay? So, in any case, this is the particles, right? They are all the different types of particles. Now, let's go to what this number is. This number that is so unique that we are making reference to in everything, whether we are talking about atomic substance, or we are talking about molecular substance, or we are talking about ionic substance, which is formula. We are always referring to this same number, 6.02 times 10 to the power of 23. Now, first of all, this number, is it a big number or a small number? Obviously, it's a big number. Obviously, it's a big number. Why? Because this is raised to power 23, not raised to power minus 23. If it's raised to power minus 23, then it's a small number. Okay? If you study standard form in maths grade 10, then you understand exactly what we're saying. Okay, now these are numbering. If you have 3 zeros and any number behind it is in million, if there's 1 here, this will become 1 million from all the way from here. If there's 2 here, this will be 21 million. If there's 3 here, this will be 321 million. 3 here will be 321 billion. Now, if you pass this number labeling, and your here is in trillion, here will be 1 trillion, 21 trillion, 321 trillion. When you pass the trillion domain, you go to quadrillion. You have 1 quintillion, 21 quintillion, 321 quintillion. Then if you move to this place, we are in this sextillion. Sextillion. This let's say 2 sextillion. Let's say there's 2 here, 22 sextillion. If there's 6 here, you say 602 For example, 602 sextillion. Okay, so this is the number. This is one Avogadro constant, the number we'll be referring to. This is the number that is 6.02 times 10 to the power of 23. You can see it's a very huge number. We are saying that 1 mole of a substance contains this number of particles of atoms, of atomic substance. 1 mole of atomic substance, just 1 mole, contains these so many huge particles, of atomic substance. One mole of molecular substance contains this huge number of molecules. 1 mole of ionic substance contains this huge formula unit of the substance. Okay? Now we move on. How big is a mole? Therefore, it means a mole is big if 1 mole contains that huge number. So 1 mole of marble will cover the entire earth. Yes, because of the number you just gave. 1 mole of a marble will cover the entire earth. Ocean included the land and the ocean, for depth of 3 miles. Depth of 3 miles. So 1 mole. So 1 mole of $100 bills stacked up on top of another will reach to the sun or to Pluto and back 7.5 million times. So you can figure this out, how big a mole is. You keep $100 bills, $100. You're keeping them on top of each other. 1 mole will reach to the sun and come back 7.5 million times, going, coming. So you can see how huge a mole is. It's not because of the number of particles that is made up of. So it would take a light 9,500 years to travel from the bottom of the top of a stack of 1 mole of the $100 bill. This number 1.14. This is not small number of years, okay, for this to happen. Okay, now let's move on. Let's move on quickly. Now, can you imagine how big Avogadro's number is? Can you imagine how big it is? It's super big. The number is extremely big, but atoms and molecules and ions are too many to be counted. So they account for this number. Atoms, molecules, and ions, they are very big, so they represent this number. Okay? So why this number 6.02 times 10 to the power of 23? Because this number is the number of atoms in 12 grams of carbon-12 isotope. This number is the number of atoms, relative atomic masses. They are based on carbon-12 isotope. All relative atomic masses, they are based on carbon-12 isotope. They are based on what? Carbon-12 isotope. So everything is weighed based on carbon-12 isotope. And you can see millions of particles. This one is. There are millions and zillions of particles that are in this substance alone. Such is what this number represents. And they are based on carbon-12 isotope. They represent carbon-12. They are based on carbon-12 isotope. According to International Union of Pure and Applied Chemistry, which is called AUPAC, the new definition of mole will be as follows. Mole will be defined, the mole with the symbol MO, MOL, this is the symbol. The mole will be is the Avogadro's number. So Na is equal to 6.02 times 10 to the power of 23 per mole. Okay, now number of mole, since we now relate them, number of mole will be what? So we use small n to represent mole. Number of mole is equal to the number of particles. So number of particles, I'll use NO, then I put small slash at the bottom. So this one means number. Mole of that thing multiplied by the Avogadro's. But if you're looking for the mole and you are given number of particles, this one divided by the Avogadro's constant. Is that okay? Okay, we'll move on. Now let's take an example. Let's solve this example. You say, how many atoms are there in 0.2 mole? Right? They're asking for the number of particles. And we say number of particles, look at it. We say number of particles is mole times Avogadro's constant. So we say mole times Avogadro. So number of particles, so I'll just say particle. Let's use P for particle. Number of particles is equal to mole, which is 0.2, times Avogadro's. Formula, number of particles equals to mole times Avogadro's constant. So you apply number of particles is, the particles could be atoms, like in this case they measure atoms, could be molecules. They can ask you how many molecules, calculate the number of molecules, or it could be ions. If it's ions, their formula, they may use the word formula. Okay, whichever word they use here is the same formula, the same way. They all represent particles. Okay, so when you multiply, then you get the number of particles. When we multiply, we get the number of particles to be 1.204 times 10 to the power of 23 atoms. This is the number of atoms you get. Is that okay? Now let's move to another problem. Okay, you can press your calculator. 0.2 times 6.02. You just need to multiply only the numbers. You just need to what? Multiply only the numbers. Just take your calculator. 1.204 times 10 to the power of 23. This 23. You just bring it times 10 to the power of 23. This is what you will get. Times 10 to the power of 23. Is that okay? Times 10 to the power of 23. So this will help us very concisely. Now let's move on to another question. For example, if you're given a sample of zinc chloride, look at zinc chloride, contains this unit. When they use unit, they talk about the ion, right? Because this is ion. Zinc, positive ion, this chlorine minus, right? Ion. This is ionic. So, okay. So here, mole is what? Mole is number of particles. Particles is divided into atoms, into molecules, and into units or into ions. So 3.01 times, really? We are divided, right? Is this one? Yeah, 5 moles. Okay? So you need to pause, write. All this you need to write in your notebook and enhance your calculations and enhance your studies. Okay? So we go to another example. We're going to break this into 3 segments, so 2 or 3 segments. So after the particles, we stop here, and then we'll move on to the next one. Now, let's say a gas jar is filled with 2 moles of oxygen gas. So they've given us the mole. A gas jar is filled with 2 moles of oxygen gas. Okay? How many molecules of oxygen are there in the gas jar? Remember, molecule is the same as particle, right? So remember that mole is equal to particle over Avogadro. Mole is a particle over Avogadro. Power of 20 times 10 to the power of 20. That's it. That's the molecules. You write molecules, okay? Say this number of molecules. The A part of it. The B part is how many atoms of oxygen are there in this gas? Oxygen is O2, right? So O2. So we will use that effect to divide. You see the molecule? We multiply. If the molecule is 1.02, since oxygen is O2, you multiply to get the atoms, you multiply by 2. Yeah, 1 molecule of oxygen equals to 2 atoms. This is 1 molecule of oxygen. Okay? This is 1 molecule of oxygen and it's equivalent to 2 atoms. So to get the number of atoms, this molecule answer I got, I will multiply it by 2. We will multiply it by 2. So that's for the B. For the B, this is for molecule. Number of molecules. To get for the number of, right? We get 2. For the B, you get 2.408 times 10 to the power of 24 atoms. You have to write atoms. This one, remember we are calculating the atoms. We are calculating the number of atoms. Okay, so I think we will stop this part 1 here. And next class, we will go for mole and mass and molar mass. Is that okay? So with this, we've come to the end of our class today. With this, thank you for joining us. Thank you.